This is the coil secondary waveform using this supplied ignition probe. This display is from a lawnmower. It's the only thing I had around that wasn't coil on plug. This is the ignition probe on a Toyota 4-wire coil on plug. You need to find one spot where it will pick up a pulse. But if you have OBD2 code for a cylinder, you wouldn't need to scan for a pulse. If you had a crank no start with no codes, you might use some of these tests. This is the probe made from a relay coil. The idea came from Mechanical Mindset YouTube channel. The connections to the coil only remove diodes or anything but the coil. This is the ignition coil pattern from probing the battery plus to the ground on the coil itself. We're looking at voltage fluctuations caused by the coil firing.
Microsecond speed, and I messed with the trigger. I couldn't find make any difference with the trigger. Let's see if we can hold that. Yeah, so we can hold that and we get a good use. I mean, that's the pattern I was looking for. We're on the positive and the minus on this 4-wire Toyota coil.
We're probing battery to IGF. This displays the signal from the coils to the ECO over a common wire. Divide the frequency by the number of cylinders and you'll have the RPM. Now we're plugged into the IGT terminal and plus 12. You can see the square wave, but I can't trigger it very well. If you probe battery to IGT, this signal is from the ECU telling the coil to fire. So of course, the frequency will give you the RPM because it's one plug firing. This is can high. Can high and can low can be displayed on the scope one at a time. I'm connected to a breakout box, but you would use this to see if an unresponsive module is receiving can data. This is the same CAN bus data on the O1 scope. And it's 2 channels, so I can display both CAN high and CAN low. The DM303 will decode CAN bus data. It looks to me to be in hexadecimal form. That's an option rather than looking at waveforms and trying to see if it should be readable by the module or the ECM. Theoretically, if the DM303 can read the CAN bus, then the module ought to be able to read it too. This demonstrates how you can use the DM303 to test wheel speed sensors. This is a GM hub that was removed from a car, and it's easier for me to demonstrate it in a vise than by picking a car up. But anyway, you can spin the wheel, and you can see the display. If you have a good wheel speed sensor, you can see it. If you had a question whether or not that you had a broken wire or a bad wheel speed sensor, that's when you'd use that. Function generator. This is the display of the DM303 function generator connected to a bench scope. It is 5 volts because it's running on the internal battery. It would be 12 volts if I had connected it to a 12 volt battery. This is scope waveform. We're looking at the fuel pump current through a 1/2 ohm resistor. This is looking at fuel injection with the probes just across the fuse. Power probe functions. Battery plus. And down arrow is battery minus, which doesn't do anything because I'm not on positive. Battery plus. The current seems to be limited. This didn't come with the DM303. I bought it separately. This is my resistor, which was separate. This is how you can lengthen the cable. These are generic. You can use a Hanatech current probe with it, and it will measure current without breaking the circuit. Of course, you can measure current by doing it in series with the meter itself. You may be able to use accessories from other scopes. And this is a secondary ignition probe from an OTC scope. The probe supplied with the DM303 is better.